Hey everybody, I'm Marcus Hazelwood, and welcome to Clear Haze Exchange. I'm an energy engineer with over 15 years of experience in sustainability and energy efficiency consulting. Many find these topics a little complex, so I created Clear Haze Exchange to help provide clear, actionable insight. Clearing the haze, so to speak. We'll cover plenty of topics under the umbrella of energy efficiency and sustainability. Let's get into today's conversation. So, Anastasia, you are a technical director for CIBSE, Chartered Institute of Building Services Engineers in England. Thank you for joining the show.
Thank you very much. Hi, Marcus. Thank you for the invitation.
Yeah,
CIBSE is not just in England. We are a global institution, so we represent the industry, and our members are international all over the world.
great. That's good. So, as a technical, diving right in here, as
Mm-hmm.
a technical director, and is CIBSE, is there a short name for it, or you usually say the
We
acronym?
just say CIBSE.
CIBSE. Okay.
Yeah,
That,
CIBSE.
that'll help me. So then
Yes.
I won't say it pronounce it that way. No, I'm familiar because I worked on campus to where we used a lot of acronyms, and
Mm.
so it was kind of I had to always think when we had meetings for people or consultants outside that I had to slow down and make sure I said them right or explain what they are. So certainly familiar with that. So CIBSE,
Yes, CIBSE. It's fine.
good. So as a technical director at CIBSE, how do you define and prioritize the institution's technical vision and knowledge agenda?
We are very fortunate as an institution. We have 24,000 members, and a big portion of these members are really kind of passionate volunteers. They are very involved in complex and well coordinated structure of groups, working groups, and societies and networks. And they're very good in getting involved and telling us, well, me, the technical director, my team, but also CIBSE, what we should be looking at in the future. So that is a huge kind of insight into what is relevant in the industry now, but also what is coming in the future. But we also have very good collaborations with other institutions, leaders in the industry, but also with academia. I think that's a very important aspect of what we do. Look at where the research and the innovation is going to be in the future, and we establish these kind of collaborations and links so that they help us build up our knowledge and our expertise.
That's good. And like you said, it's a very broad. You said it's in England and what other parts did you say?
So we represent and we provide kind of guidance and standards for building service engineers all over the world. The UK, of course, including the devolved administrations, but also we have kind of regional chapters around the world, like Australia, New Zealand, UAE, Hong Kong, and we have members in various other areas.
So you played a significant role in advising the government on Part O regarding overheating and new dwellings. Could you explain a little bit about what Part O is?
Yeah, so part O is there's many parts in the building regulations looking at different aspects of a building performance and building design, mostly concentrating on health and well-being and safety of the occupants. Part O conveniently is addressing overheating risk. So as the climate warms up and we use too much glass in our buildings, urbanization, high insulation, there's all these different aspects that they contribute to our buildings get kind of more hot, especially during the summer. So Part O was designed to address that. So designers, when they architects and building engineers, when they design a building, now they're required to look at the risk of overheating in that building. So they would create a model, they will look at the energy performance, they will look at other aspects of the building, they will also have to look at summertime performance.
What are the biggest challenges in shaping this regulation?
So shaping the regulation wasn't as the policy, the kind of the policy document, it wasn't as challenging. I guess the challenge was mainly to gather the evidence to support the need for a policy and for regulation. That took many, many years because, of course, the the climate in the UK is primarily cold, so you want to keep buildings warm in the winter. And for a long time, nobody was looking really at what happens in the summer in the same buildings. So nobody was monitoring temperatures, for example, gathering evidence, having complaints. So gathering kind of that evidence to support our claim that actually this is an issue that needs to be addressed by regulation. I think that was the biggest challenge. But once we got there, and we convinced government, then actually putting the policy together, it wasn't, well, personally, I don't think it was the biggest challenge.
So, what part of that in policy is it for approving design of buildings or requiring existing buildings? How did it apply direct to the owners?
Yeah, it doesn't apply directly to the owners. It's for the people that design the building and they put the kind of the planning application, and it's for new build only. So that is the kind of the next thing I think that we need. Well, the government needs to be looking at having equivalent to Part O, but for existing buildings. So how do you kind of refurbish what are your options and how do you refurbish a building, existing building, so that you avoid overheating?
That makes sense. So, could you elaborate on how, because this is really going to get us into the topic of embodied carbon and the
Mm-hmm.
circular
Mm-hmm.
economy. Right now, we're kind of you're speaking a little bit more on that comfort
Mm-hmm.
of occupants, but also understanding how we're utilizing those resources that we extract in order to gain that comfort. And all of this obviously impacts greenhouse gas emissions
Mm-hmm.
and climate change. So, could you elaborate on the importance of embodied carbon and circular economy principles in the context of building services engineering?
So so there are two elements in a building, in a building's kind of construction and performance. One is the material, the equipment, all that has what we call an embodied carbon. So you use energy to create the material, to extract them, to move them from one place to another, to construct the building. So all that is kind of the embodied carbon of the building. And the other part, of course, is the operational carbon. That is the energy that you use to have a functional building. Um, and so far, we've been really kind of concentrating on reducing our demand, our operational energy. So it's switching off the lights and not using energy when you don't need it, and so that's kind of the operational at a very kind of basic level. We did the kind of a design, but also at occupant level behavior. We understand that very, very well. We know when we are using energy, we have smart meters, all that. But the next step now is to understand and calculate, measure, and minimize our embodied carbon, because that is going to be the next big source of carbon emissions that we will have to address. So that's the embodied carbon.
It's a very important topic. Go ahead.
And I guess the important, because you asked specifically for the building services embodied carbon. Um, it's important that we address that because they are a big part of a building. So the building has the construction, so it has the concrete and the blocks and the wood and these elements. But also we put all the air condition and the boilers and the pipes um, and that the material comes from kind of sources that they're not always renewable. We use rare metals to construct and to manufacture these kind of systems. We use refrigerants. Those are really kind of high impact. greenhouse emission impact. So having a focus on reducing the embodied carbon of our building service equipment, I think, is very, very important for the industry.
Yes, yes, absolutely. In the UK, it seems there's a lot more progress in that area than in
Mm,
the US. It is growing in the US. I worked on the East Coast
yeah,
and worked on projects on the West Coast from New York to California. There are kind of more aggressive pathways towards looking at and understanding embodied carbon and incorporating that into the
mm,
design. But it's certainly a hot topic because, as you said, we're thinking about operational carbon a lot, but that embodied carbon for the materials that actually are pulled from the resources to actually create those boilers and those chillers to contribute to then the operational carbon, but we have to think about that embodied carbon
absolutely,
piece.
yeah. And where they come from, where do you buy that equipment? Where does it have to be transported from? That's also kind of part of the embodied carbon of that piece of kit that you put into your building.
Yes, absolutely.
Mm.
So it's interesting though. So your career started in architecture
Yes.
and transitioned into environmental performance and climate research. So
Mhm.
how has this multidisciplinary background shaped your approach at CIBSE?
I think it is very important. Well, I found it very valuable to understand the point of view of the different disciplines. So, what are the priorities for an architect when they design a building? What is the priority of the building service, of the structural engineer? And in that way, you can kind of adapt your arguments and your point of view to those kind of priorities and have a bigger impact in terms of what you are saying and how it's going to be implemented in the building. So in a way, it was fortunate that I kind of looked at different different disciplines within the industry because that definitely shaped my understanding kind of more holistically of the priorities and communication between the team.
Yes, absolutely. Because that's just from my experiences on the engineering side, being able to communicate all these details, especially in the space of energy modeling, when you're bringing all that, the architectural and the engineering systems together, it's helpful to have that great knowledge of the different disciplines and informing something like SIPSE and where you're forming in these part O and the heating of buildings because you then get that depth of knowledge behind the engineering systems, the design of those, what's important, what's needed. But then at the same time, your architectural background, thinking about that from the architectural standpoint. I was recently having a conversation around our values with someone who will be on the podcast as well, the importance of understanding that from an architectural standpoint,
Hmm. Hmm.
because it then affects the engineering side on how you build an energy model to properly understand how those systems perform. So that really exciting stuff to see that multidisciplinary background and knowing that that kind of gives you the validity and the direction you're giving from your organization.
Absolutely, yes, uh, and and it is important, I think, for a successful, well-designed building to have that depth of understanding between the disciplines, and also to tackle all the kind of the challenges that we are facing. The trying to achieve our net zero targets and climate resilience. We all need to speak the same language.
For sure. So what trends or innovations are you currently most excited about? There's so many out there as far as
Mm,
technologies
mm, mm.
in relation to sustainable building and design and engineering.
The thing that I'm most excited about is how AI is going to shape the industry. I hear already from our members that they are using AI in different ways. To design, to do calculations, to interrogate their designs. So that's one part, like all the tools that they are available to us like, so quickly, but also the idea of analyzing data we get, like you said, a lot of technologies, smart metering, monitoring of indoor environments. In the past, somebody had to sit and go through thousands and thousands of lines of raw data. Now you can use AI to just analyze it, ask it how you want it to be presented, and you can get so much depth and so much kind of feedback loops to improve existing buildings, but also kind of design new buildings. So I'm really, really excited to see how is that going to kind of develop in the near future and longer term. I think the fact that we are embracing AI and technologies will bring a lot of young engineers in, a lot of diversity in our industry, but also it's going to expand our remit as well. So we're not just kind of building things and installing things, but we start thinking about digital engineering, digital tools, visualization, 3D, whatever. It's expanding all of a sudden a really kind of traditional and old-fashioned industry. So I think it's a great time now to be an engineer.
Yeah. Oh, that's good. That's an interesting perspective. I like it. I like it a lot. So with that said, though, what are the biggest gaps you see in between AI and what things are happening now versus what things the goals that we're moving towards?
Mhm.
Um, Having these tools, being able to kind of navigate through all this data better with AI, but what are some of the gaps or
I
challenges?
think the gaps are so the technology is moving much faster than the infrastructure and policies to support it. So, how do you use AI? What is a good way to use it? What is a bad way to use it? What about cybersecurity? Until recently, I didn't even know that anything you upload becomes public knowledge. The idea of having a secure AI where you can upload things to analyze. How do you secure all the data and all the information that you have? So I think um, the thing is that technology is moving faster um, than the kind of regulatory framework and guidance. So we will learn by doing, and that creates risks that we don't know yet.
What would you say that how that applies to current building regulations or standards when it comes to climate resilience?
It's a difficult question. How do you translate data, I guess, to inform? Is that the kind of the question? How do you use information and AI to increase the resilience of buildings?
Yeah, it's similar to kind of piggybacking on the point of the gaps you were explaining
All
around
right.
the difference between AI and, and what we have now with the challenges we're facing and the gaps. How would you
Okay.
say those gaps apply in terms of building
Climate resilience.
regulations and standards,
Okay.
climate resilience? Yeah.
Okay. Well, when we are talking about climate resilience, I think the next global um, challenge will be in terms of building level. It will be how do you cool it? How do you deal with increasing temperatures, right? So a lot of countries have already adopted air conditioning that is slippery slope, because as we're reducing our heating demand, our cooling demand is going to go up. And then, electricity is expensive, you have energy poverty. So, an area that at CIBSE, with my team, we are looking to invest quite a lot of resource and time is on sustainable cooling strategies. Other countries already have dealt with alternative cooling strategies. They are moving away from intense air conditioning use in buildings. How can we learn from them? What should be kind of the UK's position in sustainable cooling? Okay, we used the Part O and we calculated our overheating risk. We found that it's high. Then what do? You can't use the boiler. What do you do to adapt your building without actually installing an air conditioning unit? So I think that's a big gap in terms of building services and building performance.
Rolling that into, as you pointed, with CIBSE helping
Mm, mm,
roll that into new construction design, those
yeah.
decisions. It sounds like you're more effective, or you can be more effective in terms of regulation and standards with new construction than with existing buildings for a lot of straightforward reasons. How do you see that the approach with that changing with existing buildings? Is there a way to kind of mitigate, reduce the challenge?
The challenge, like you said, is always going to be bigger in existing buildings. So making sure that we don't build any more buildings in the wrong way, it's fundamental, right? So as engineers, that is our responsibility, making sure that we don't design and we don't build kind of the wrong buildings, or buildings that they're going to have huge energy implications in the future. Um, for existing buildings, there are ways that, but it's more to do. I mean, you have the basic kind of you close your curtains, you put external shading, you plant more kind of green trees in your garden for shading. You open your windows, but it's mainly to do with occupant behavior, I think, making sure which rooms in your property are the coolest, knowing when to close the windows because outside is hotter, using fans. Fans are very effective mitigation option. We use it a lot. I come from Greece. We use it a lot there to circulate the air and kind of create that draft that it has a cooling effect. So there are options in existing buildings, but we will have to do quite a lot of awareness raising that we have been doing with CIBSE quite a lot, talking to media, doing little videos and little stories, case studies, just to show people how they can kind of survive a heat wave in their homes.
I had a guest on that was talking about the importance of storytelling. So what strategies are you seeing to be effective in communicating those things?
I think social media and having little videos explaining very simply to people basic concepts, and I think that would be the most effective way, because everybody's on their phone, on Instagram and TikTok and whatever else. It's the latest. So having awareness raising little, I don't know, a minute, is that acceptable now? I don't know if does it have to be less than a minute?
Yeah,
Um, to promote good practice. I think that is certainly something that we are looking to do.
it's the attention span. It's almost kind of like I think about. I have a 2-year-old and a 4-year-old. To keep them entertained in a way is the same way that not even and it's not a thing, but as adults, when you're scrolling through,
Mm,
you're just kind of looking at things, and something has to really catch your attention to really,
yeah,
spend more time on it. And it has to be
absolutely.
short because then you're moving on. If it's interesting enough to where it's 30 seconds or under a minute, then you might look at it and take something from it, but then you're moving on because there's so much information out there.
Absolutely. I think marketing and comms it's a fundamental aspect in having the right tone, the right medium, the right visuals. So I guess that it's another really exciting area that we are developing within CIBSE, understanding how do you explain engineering to everybody that everybody gets excited about.
Yeah, that's a challenge, but also a very valuable one to
Mm,
achieve is the ability to communicate that. So that's exciting. So back to the side of education. So you're
mm,
a chartered engineer
mhm,
and a CIBSE member. which is equivalent of a master's program or the highest level of education in the U.S. So, why was this recognition or education valuable to you?
For me, it's a clear route to professional development. You have an established framework where you continue your professional kind of upskilling constantly, and being part of the CIBSE kind of membership and CIBSE world, you get that constantly. You get your CPDs, your events, you get training, you get knowledge, you get updates, newsletters. It's a constant way of keeping up to date with everything, and a huge resource for picking and choosing the areas that you want to do more concentrating. For example, is it heat pumps or is it climate resilient? What you have a kind of such a variety of topics in so many different ways to absorb the information that for me that is invaluable.
That's good. So, and we mentioned your background in
Mm,
architecture.
hmm
So, how is your background in architecture and PhD research on highly glazed buildings, and
hmm
how has that influenced your approach to tackling overheating and energy
mm.
performance issues?
Well, I'll give you an example, Marcus. For example, as an architect, you have an office building, right? You have a client. They want to design a really fancy office building. As an architect, you think about daylight, you think about transparency, you think about fully glazed building. Then, of course, when you look at it at the performance, you look at the implications of the decisions you have made as an architect to the actual performance of the building. So that was my journey. That was okay. So you design all these fancy, beautiful buildings. How do they perform? What does it mean in terms of energy use, in terms of occupant satisfaction? For example, now I sit next to this window and I get glare. How do you deal with that? So it looks great when you walk outside and you look at it, but what about the people and the performance of this building?
As a design professional, you're in the weeds of the details and the
Mm,
technical things
mhm,
versus the research side, you actually have the time to think about the data and the data that's produced. So, with balancing those two, how have you found a pathway in your research focus, but still you're dealing with real world as you're informing regulation and standards. So, is kind of piggyback on a question I asked earlier in
mm,
the
mm,
balance of those
mm,
two.
mm, mm.
Could you speak a little bit more to that?
Um, I guess as a professional, you build your knowledge, right? You start with the building, you then analyze the data, like you said, then you get more into the kind of the policy and the regulation framework. So I think the main thing is that you stay curious and you go from one step, okay, I understand that. What about this now? What about that? And I think it's part of a good engineer to always stay curious and want to know more about other other disciplines and how they kind of affect their design and their decisions.
That's good. So how does your team at CIBSE collaborate with academia and industry to develop forward thinking technical guidance? So how do you and your team interact?
We have very, very close links with academia and with industry. We have a dedicated resource. We have a research manager that is actually her job is to sit in advisory boards and partnering with academic institutions, looking at what is the next thing that is coming, bringing it in. And we have a research fund, so a dedicated pot of money to invest in research and innovation. We have our own conferences. We are involved in conferences. The kind of networking, talking to people. So it's part of our job as our kind of outreach to academia and industry to identify best practice, innovation, and bringing it in, developing it, getting the knowledge out to our members.
And do you get collect a lot of data from different universities on performance and
Um, we don't collect. I mean, we collaborate with universities to um, to collect, analyze data. So, for example, we have an ongoing project with UCL on energy benchmarking. So we are looking at the energy demand of various types of buildings. We have, for example, a large sample, let's say 500 schools, right? You analyze that and you create a benchmark. What is a well-performing school? What is a kind of average? What is a bad performing? So that was a really good, kind of exciting project. And we have a similar kind of project in terms of collecting embodied carbon data. So you have, I don't know, 100 different types of boilers. What is their embodied carbon? How can we benchmark again? What is the high embodied carbon, low embodied, average? So yes, we do quite a lot in kind of this area of either collecting data or assisting in using data to inform tools and design guidance.
you guys have much interaction for the audience, leadership in energy design, and then in the UK, BREEAM is a green building certifier that's typical in the design world for buildings to achieve green building certifications. Do you guys do or does CIBSE get involved much with supporting those types of organizations?
So we have our own certification team, and we have, I don't know if you know Neighbors. It's called Neighbors, and it's basically a certification scheme of operational energy in buildings. So basically, buildings need to accumulate, measure their energy performance, the energy data, and then they submit it, and there is an assessment kind of a period, and um, they get a rating at the end of it based on their energy, and an advice on how to reduce their energy demand as well. So that's quite popular in the UK. We're also we collaborated with other institutions to create a net zero carbon building standard. I don't know if you've heard of it. It was just launched last year, end of last year, and it's a major initiative in our industry. One of the very few times where everybody got together, the architects, the structurals, the mechanicals, the big players in the industry, and they said, right, what does net zero mean? How do we get there? And we created this kind of standard that provides the roadmap, the targets, the limits. It looks at operation, it looks at embodied. It's a really, really, really good piece of work that we are all very, very proud of. And that is going to have a kind of a certification route where buildings can be certified against it.
This topic of net zero and how we achieve
Mm,
that.
mm.
What does it mean for different areas? I mean, is it net zero, net negative, net zero capable? So there's different ways from a marketing standpoint that
Yes,
that
for sure.
people they see that. But it's exciting to see the work of digesting it and making it applicable. And also really because that's what's important, right?
Yeah.
So
Yeah.
how are you seeing that that concept, the net zero concept,
Mhm.
working in terms of translating for people to understand?
Um, so this is, of course, this is another kind of comms challenge, isn't it? So you have the kind of the technical detail that goes into a standard, and that is specifically, I guess, for industry people to understand, digest, comply with it. But it's the bigger kind of awareness raising um, for the rest of the rest of the people, the clients, the occupants, the everybody to understand what we mean by net zero, and the idea of that we stop using fossil fuel. Basically, that's basically what it says, right? And you generate the energy that you need, and And in order to do that, you need to basically reduce your energy demand. Um, and they're all kind of basic concepts, but very difficult, I guess, to achieve and to communicate. So we are working again to look at how do we do that? How do we communicate those kind of principles?
So, what advice would you give young engineers or architects interested in contributing to climate adaptive building design, net zero, and technical leadership? All these great topics in this world that are very important.
Um, for me, the building engineers, the building professionals, they are the superheroes of our generation. They are the people that are going to create environments where people thrive. They're healthy. They're safe. They enjoy their time in them, and all that without actually costing the earth. So, so I would encourage young people to join engineering, and I would encourage young engineers to be aspirational, to bring new ideas into their meetings. I really, really enjoy working with younger members of my team. They come with all these kind of great ideas, um, and and um, and we need to empower, like the older generation engineers. We need to empower kind of young engineers, and making sure that um, they can achieve what they want to achieve.
Good. So, but reflecting on your time as head of research at CIBSE, what project or initiative are you most proud of, and why?
I have to say, the embodied carbon methodology, we call it TM65, because the technical memorandum number 65. But ultimately, how many years ago? About 5 years ago, 6 years ago, um, we arranged that workshop, and we sat around the table. We discussed for a couple of hours more how we're going to tackle this, how we're going to measure this embodied carbon. Is this elusive thing that it just is so complex, and it's so detailed, and the information is missing, and all that. Um, and at the end, we kind of went away thinking it's impossible. We'll just leave it for now. But then we had a follow-on discussion with some people that they were actually doing something. And you know what they say? Sometimes the perfect is the enemy of the good. And we agreed that we will need to have a step-by-step approach. So we said, okay, it's not perfect, but it gives us kind of the first step of understanding what are the key elements in a piece of kit, in a piece of equipment that contribute the majority of the kind of the carbon. Is it the metals? Is it the transportation? Is it the manufacturing process? So we started very, very kind of slowly to build on this kind of methodology that now everybody's using. In America, they're using it, in the UAE, Australia, all over the world, they're using this kind of methodology to start understanding and calculating the embodied carbon of building service equipment. So I'm really proud of that.
Good. That's what I love about this is understanding that even as a technical expert, there's still challenges in the data, and that need to be understood and flushed out, and to be able to attack those and bring vision and understanding and good practice out of that is like you said, a great mission. So your work is really made a significant contribution to CIBSE's guidance on climate change and adaptation. What do you consider is the most urgent climate related risk for buildings today?
I think that the next challenge would be to cool our buildings in a sustainable way. I think that is something that we should be looking into understanding better, bringing more knowledge from abroad, adapting our buildings so that they don't require intensive cooling, air conditioning. I think that for me is the kind of the next challenge in the area of climate adaptation.
Yeah, and it makes sense. And you mentioned refrigerants. Refrigerants, just on that topic, there's some that have a global greenhouse gas emissions and impact
Hmm.
that is greater than others. Of course, the older refrigerants have a larger impact.
Hmm.
What would you say about in terms of refrigerants and the track towards what are better refrigerants, most effective? How do you balance that
Um,
conversation?
from my point of view, it's relatively early days. It's a developing area. So we have established that the old refrigerants are kind of high emissions, high greenhouse emissions. What are the alternatives? And there are alternatives, but it will take a little bit of time, I think, to be adopted, to be certified, to be implemented. There are other considerations that we need to think. We're trying to fix one thing. Let's not break something else. What is the safety? So there's going to be. I think everything is going towards the kind of the right direction. It's just as always, things take a little bit of time for the kind of industry and manufacturers and to adopt all that. But I think it's inevitable. We can't continue using the refrigerants that we have been using. It's insane.
You did a lot of research on weather files,
Yes.
and the research behind that and understanding that, and as an energy modeler myself,
Yeah.
understanding those TMYs and that weather data is
Yeah.
a very, very critical piece to understanding how these designs are actually going to perform to make the best decisions about our building systems. So at CIBSE, weather files and technical memoranda like TM52 and TM59, they've become essential tools really, because like you said, with building heat, understanding what is that it's essentially a heat transfer. You have your building, this little bubble that people are
Hmm.
inside of. And when it's hot outside, if that heat gets inside, how do you keep, that inside cool, and then vice versa in the winter? So what are the key challenges in developing these resources, the weather data?
I wouldn't say it's a talent. It's what we do. We develop guidance and tools for our industry to calculate all these kind of implications to indoor environment, that kind of interaction between indoor and outdoor. It's, I guess, having the right data is important. We are very fortunate in the UK. We have the Met Office and the climate projections. So what we can do is we can create kind of weather profiles that they are representative of current climate, but also in the future as well. So in that way, you can look at how your building is performing now, but also how it performs in the future. Um, it's all very exciting because you have all this data and you can analyze it in various different ways, and there are all the questions about, do you use extremes? Do you use averages? Which scenario are we going with low? Are we going with average? What the IPCC saying about what's, what's the most kind of probable scenario in the future. So it's all good fun, but ultimately you create something for the industry, and the weather files plus the kind of the overheating assessments and the criteria are fundamental. And as you said, they have attracted quite a lot of interest internationally as well.
And there's a lot of data there,
Yeah,
and a lot to sift through. So I certainly can understand, and where you said, the value of AI being able to take all that data,
correct.
especially when you're pinpointing a specific area, and what the weather trends have been for a specific area, and
Hmm.
being able to pull heating degree days, cooling degree days, and all that data. Because the other piece to it is that, if someone has great data, then you can use that to make better informed decisions, and that's certainly a great value.
Yes.
But what I guess, to flip that question in a way of, I know that there's not many challenges in developing these resources, but what are you seeing the need on the design professional side in terms of they know that this data is accessible, but do they all? Is there a challenge in how they're able to translate the use of it effectively, in terms of if they need to, design a building, and there are values, there are values and their insulation values, um, how they perform against different weather conditions. Are you seeing that different modeling softwares or different softwares are able to simplify pulling the right data, weather data needed, or is there different
I
challenges in that area?
I guess that's where the engineering expertise come in, right? As an engineer, you are interrogating the data based on your experience and previous kind of experience in what you are expecting to see. So, a good engineer will. It doesn't matter what the tool is. They will be able to interrogate the data that they get out of that tool. But something that I'm quite keen to promote, especially when you're looking at future scenarios, is risk-based decisions. So in the past, we said this is how the climate is going to be, so this is how we're going to size our boiler, let's say. Now we don't know really. There is huge uncertainty how the climate is going to change in the future. What the extremes are going to be, the high extremes, the low extremes. So how do you design a system to be able, or a set of systems in order to be able to cover every eventuality? At which point do you say, no, this is too much. We're just going to let people go home, for example. Um, so there is that kind of element of uncertainty that um, engineers are not really comfortable with, because they're liable. If the building doesn't perform, then it's they didn't do their job right. But ultimately, we all, engineers, but also clients, need to understand that there is a certain level of uncertainty that we are dealing with in the future, and and what happens when you have reached the capacity, basically. What is your plan?
Good. So, looking ahead, what do you see as most critical technical priorities for the built environment sector over the next decade?
Um, I think our our ultimate goal is to achieve energy security. We need to have a sustainable way of living, um, and buildings have a huge part to play in this. And for me, that is, we have all these tools, all these technologies, all these expertise. Now we need to make them, to put them into practice, to reach kind of that net zero, or energy security, or energy independence, or however people want to call it. It's all basically the same thing. It's using the energy that we produce rather than relying on fossil fuel.
That's good. I appreciate your time in answering these questions. Excellent, excellent wealth of knowledge
Thank you.
from you, Anastasia.
Thank you very much.
But I thank you for helping clear the haze around climate impacts, building services engineering, and your career as a technical director at CIBSE. Um, yeah, thanks a lot.
Thank you, Marcus. Nice to meet you, and always nice to talk about engineering.
Thanks for listening to Clear Haze Exchange. New episodes drop every 2 weeks. You can catch Clear Haze Exchange on Apple Podcasts, Spotify, Pandora, iHeartRadio, and more. Let's clear the haze about sustainability and energy efficiency together. Subscribe now and join the conversation.